In this video, we're going to use parametric equations to simulate two wheels spinning against each other. So you've got a big wheel of radius A and a small wheel of radius B. And as well, the two particles starts here and here. So as the particle on the big wheel spins around, the particle on the small wheel will spin in the other direction. So this is anti-clockwise and this is clockwise. So let me just show it to you. Hang on. So you've got two circles of radius A. So radius A. Hang on. So radius A, and you've got the other circle of radius B. So both particles starts right here. So let me just press play. Oops, wrong one. Bear with me. Let me just press play. There. So you've got the particle on the big wheel spinning around. This one here spins in the other direction. So we're going to use parametric equations to model this. So let's start out with a new graph. Hang on. So first create a big circle. So that would be of radius A. I'm expecting you to know this. A cos t, comma A sine t. I'm expecting you to know why it's A cos t and A sine t. A sine t. And then add a slider. A represents our radius. We want the radius to range from 0 to, let's say, 10. Okay, so we've got our circle of t ranges from 0 to 2 pi. And then now you can change your circle. You can change the radius of your circle. So now add a second circle. Hang on, let's make this a bit bigger. So add our second circle. Our second circle has radius B. B cos t, comma B sine t. Close it off. Add our slider. And t ranges from 0 to 2 pi. So now we've got our second circle. The radius ranges from 0 to, let's say, 10. So now we can change our radius. Now we want to get them side by side. So if you look at the x component of the green circle, so this is the x component of the green circle. If you add the radius of the red circle in the x component, so plus a, it would take you to the edge. It would take you to the edge of the red circle, because look, it would take you to the edge of the red circle. And now that's not enough. We want the two circles to be side by side. So now add the radius of the green circle, so plus b. So now two circles are side by side. So as you vary A, as you vary B, they're always side by side. So now add our two particles. So the idea here is this: we are going to use a new slider called C. So C ranges from 0 to 2 pi. Let me just use degrees to explain what's going on. Even though we work in radians, let me just use degrees to explain this. So what we do is we get the whole angle here for the time being 2 pi. We cut up into 360 equal pieces. 360 equal pieces. So if we get the whole angle, which is 2 pi, cut up into 360 equal pieces, and then so this block here represents one segment here. So if you stick a t, so as t gets incremented, let's say t equals 3, it means that well, you increment it by three of these little bits. So that would mean this: 1, 2, 3. It would take you to here. So this block here represents this small angle here, and then this t gets incremented each time. In our case, later on it will be c, because we need to add a new slider. So as c moves up here, this gets incremented accordingly. So we created a system where time, or c, it meshes up neatly with the angle, with each of these small angles. So when t equals, let's say, -5, 5 seconds earlier, so that would mean 1, 2, 3, 4, 5. The particle would have been somewhere around here. So that's the idea. So we are going to do this. Hang on. So now let's add our particle. For the particle for the red circle would be A cos C, and then comma A sine C. Close it off. Add our slider. So C represents our angle, and it moves from 0. C moves from 0 to 2 pi. So now, hang on. So now when C is 0, when the angle is 0, it starts here, and by the time it gets to 2 pi, it would have done 1 revolution. So now add a circle, add a particle to the green circle. So now add a particle for the green circle. So that would be B cos C and comma B sine C. Close it off. So now where's our particle? Bear with me. B sine. Where's our particle? Oh, wait, that change this. How do I change this? Bear with me. Oh, there's our particle right here. Our particle is right here. So we need to move it across to here. So that would be us adding the radius. The radius. Now we need to add the radius of the red circle, which is plus A in the x component, and then that would take the particle to here. Now we need to add B. Add the radius of the green circle. So now add B. So now it's right here. So now if you press play on the C, there. But the thing is, we want, hang on. The thing is, when C equals 0, we want this blue dot, this blue particle to be in the same place as a black particle. So what we need to do is this. Hang on. So currently everything's when you have a circle, and then you have let's say A cos C, comma A sine C. When C is 0, it's always defaulted in this location. But then we want the particle of this small circle to be right here. So that the two particles are next to each other. Currently, when C equals 0, the particle starts here, but we want it to start here. So looking at C, so you can imagine this as being like this: A cos the bubble here, comma A sine the bubble here. Currently, when C is 0, then it will start in this location. So if you wanted to start in this location, you need to add an extra pi over 2, and then add an extra pi over 2. So that would be you adding pi. So what you do is you have to do this. Hang on. You have to do this. So you need C in there. You need C in there. But then you need to add pi. So when C is 0, you need to inject this much of an angle in there, another pi of an angle in there, so that you're forcing the particle to start here. When time is 0, you're forcing the angle to add. Well, you need to add an extra bit of an angle, so it will be C plus pi in there. So hang on, back to this. So looking at the blue particle, we need to inject pi into the angle. So looking at the angle here, this is your angle here, C. This is your angle here, C. But when C is 0, you need to force it to start at pi. So add pi. And then for this one here, you also need to change this to add pi. Add pi. close it off. So now both particles start in the same place. Both particles start in the same place. Hang on, bear with me. So let me just get it to spin in one direction only. So me clicking on this icon here. There. Okay, but the thing is, it's not realistic because as the red wheel spins in this direction, the particle on the green wheel should spin clockwise, not anti-clockwise. Currently, both particles spin anti-clockwise. Hang on. At the moment, both particles spins in this direction, anti-clockwise. The thing is, if you have two wheels spinning against each other, if this one spins anti-clockwise, then this must spin clockwise. And if you don't believe me, then find two circles and then get them to rotate against each other. As this one spins in this direction, the other one will spin in the other direction. So now we need to make this more realistic. We need to get the blue circle to spin in the other direction. So to do that, hang on. To do that, we would need to stick a negative in front of a T because of this. Hang on. So normally when you have a circle like this, as T gets incremented, when T equals 3, it moves 1, 2, 3. So if you stick a negative in there, when T equals -3, it spins 1, 2, 3 in the other direction. So going back to here, if you want the blue particle to spin in the other direction, you would need to stick a negative in front of the C. So forcing it to count backwards, forcing the time to count backwards. So now let me set C to 0. They both start in the same place. So now if you press play, now it spins in the other direction. But so it's looking better, but it's not perfect because if you look at this, hang on, you see one revolution of the small circle should only mean the particle of the big circle moved by a small amount. So hang on, let me explain it better. One revolution around here would mean that on the big circle, the particle would probably be somewhere around here. So because this circle is smaller than this circle, at the moment, if you look at our model, 2 pi, by the time C gets to 2 pi, this particle would have done one revolution, and then this one will also have done one revolution, which is unrealistic because if this one spins once, then the particle on the big circle should only have done part of a circle. It wouldn't have done one revolution. So hang on. So our model at the moment is a bit unrealistic because look, one revolution. Well, they make one revolution. Well, at the moment it's unrealistic because I will continue in the next video. I will show you why. I will show you how we can make it more realistic in the next video. Okay. At the moment it's just unrealistic. Look, it's just unrealistic. Look, 2 pi, and they're both. By the time it gets to 2 pi, they both end at the same time. So it is unrealistic. I will show you how to make it more realistic in the next video.